Hello, my name is Sugu. I am the co-creator of Vitess, and I'm also a CTO at PlanetScale. Today, I will be talking about running MySQL on Kubernetes, more specifically about how to do that using Vitess, which is an open source project. It's a member of the CNCF. Okay? What is Vitess? Vitess is essentially what we call as a cloud-native database. There are many definitions to what cloud-native means. We'll actually cover what that means in terms of storage, and I'll talk about some of those examples and use cases. Okay. Vitess is also massively scalable. It was what we originally built Vitess for in YouTube, and later when we moved it to Google, we had to make it cloud-native. So that is, which means that it can serve huge amounts of QPS. High availability, 5 nines of availability is something that Vitess can very comfortably give you, and that we'll cover some use cases about that. And last but not the least, Vitess is MySQL compatible. That means that it uses MySQL in the backend, but also speaks the MySQL protocols. So if you are using MySQL, it makes it much easier for you to migrate into Vitess. So the coolest part of Vitess is who is using it. All the cool companies, companies like Slack, Square, GitHub, Pinterest, these are all newer companies that are showing new ways of building software in the cloud. These are the companies that are using Vitess. Like, for example, if Slack comes up and says, this is how we are running our website, people take attention and want to know how that works and want to mimic that. So that's one part that I believe is super cool about Vitess. We'll actually cover some of these use cases as we go along. For example, Slack, here they've been experiencing hypergrowth for a while, but that's not been their only challenge. Their business need has also been changing. The type of data they've been handling with has been changing. And so they needed a system that had not only the ability to grow, but also the ability to take care of changing data needs. And we'll cover something about that. So they actually were looking for a build versus buy solution, and ended up getting the best of both worlds because they could buy into Vitess and also build features that Vitess was lacking into it. So they've been a great partner of Vitess and have made some really, really awesome contributions. And they've got a tremendous success using Vitess. They are at this point almost fully migrated into it. And they love Vitess so much that Demer, who is a principal engineer, this is a quote from him, which essentially says that they are pretty much committed to using Vitess, and they think that Vitess is going to take them how much ever far they need to go, which is kind of exciting. And in light of COVID-19, there was a huge surge in usage of Slack that Slack had to scale for. And you might have seen the big tweet thread that Stuart posted. In one of those, he basically said that the infrastructure team successfully managed to maintain 5 nines of availability. And the coolest part is he has recognized PlanetScale data and our CEO, Jiten, which YA in Pristis, which basically they were using our help to help Vitess scale. So this is pretty exciting coming from someone like Stuart. So the other story is Vitess, how Square adopted Vitess. They actually started Cash App, which is a kind of like a pet project, but it kind of caught fire. People started using it and it started growing. And at some point of time, they were running it on the biggest hardware that money could buy. And it was still growing, so they had to do something about it. So they came to Vitess and said, and adopted Vitess and decided to basically migrate their app to Vitess and then shard it underneath. And I just, like a couple of days ago, I went and checked on my iPhone, on my Android, and I saw like Cash App is now one of the top applications on Android. And I believe it's the same on iPhone also. And this is all Vitess. It's because they were able to use Vitess and scale it out that they are able to maintain the traffic, the kind of traffic that Cash App currently handles. As a matter of fact, I heard that the recent surge in payments, the number of payments that Cash App has been handling has been so high that it has positively affected Square's valuation. Yeah, super exciting. The other thing, like here is a quote from Yoon Tierson, who's their manager, and that shows, she basically says that you can keep scaling Vitess, it just keeps going. There are no known limitations. So what does it mean to run Vitess on Kubernetes? So if you just took MySQL and put it in a container, and then gave it to Kubernetes and put it inside a pod and gave it to Kubernetes, then you will, this is kind of the image that you will get, right? MySQL will run and it will have its database in the local disk. So this is fine, it will run, but the problem is what happens if Kubernetes decides to reschedule your pod? That's something that Kubernetes does all the time. What it's going to do is it'll shut down this instance and then restart your MySQL in a different instance. But unfortunately, what it will also do is wipe out your disk, right? Then, so there is basically, you are essentially having left to deal with ephemeral data that Kubernetes, that you basically can't run MySQL, production type of MySQL on Kubernetes just by launching MySQL, by just moving MySQL into a pod and running it, just like you would do a stateless application, right? Because MySQL has state, you need to figure out a way to keep that data, make that data survive. So the other way you do this is by actually moving the data out of the pod, right? You basically mount a volume and then have launch only MySQL inside the pod, which means that if the pod goes down and gets rescheduled, your data is still there. But the problem is that the MySQL has to perform recovery, which takes time. So that kind of ends up in lost downtime as far as the app is concerned. So again, so this is not a setup that is viable for production. And the other problem that you have is MySQL is tuned for using a local disk, right? That's how it was built. And suddenly putting storage behind a network interface changes the performance characteristics. So if your application was originally written to use local disk and you're used to that type of latency, you'll probably notice a big difference if you moved it there. But if you just built an application with MySQL using a mounted drive and absorb those latencies in the application, it'll probably work. And there are a lot of people that still use this setup in their application, and they don't seem to be too unhappy about it. It's probably because they haven't seen the performance that you can get out of using a local storage. So there is another problem, right? So the way to solve that problem is to have a master replica setup where you have a master and you have a replica. And the whole idea is that if a master goes down, you can fail over and continue serving traffic in a replica. But Kubernetes doesn't really give you much help here. It only has like 3 types of ways. You can deploy pods, you can do stateful set, you can do deployments, or you can do a service. Stateful set is the one that comes closest for handling storage systems. But even stateful set, there is no way in Kubernetes where you can dynamically designate a master. So the only way you can do it is, for example, say pod 0 is always the master, and which means that the app will connect to pod 0 and treat it as a master, and all other pods are replica. But if a master goes down and you fail over and pod 1 becomes the master, then you cannot, Kubernetes doesn't give you any help in terms of redirecting traffic to that new master. You have to then build the glue where you somehow inform the application now that the master is now in pod 1 and not in pod 0 anymore. So this is one of the problems that you have with this type of setup. The way you solve this problem is actually you could have a proxy and you could have an orchestration layer like orchestrator, and then the orchestration layer informs the proxy, and then the app server can kind of be unaware of this. There are some people who have done DNS servers where things where you update the DNS and then that redirects the traffic correctly. There are also other problems, right? When, like, if you bring up a new replica, then first of all, initializing that replica is a problem. If you are a typical DBA, you do that step as manually, and you have some scripts that initialize that replica, point it to the master, etc., etc. But Kubernetes wants you to automate all of that. So those are all rules that should be inside your pod. So when it brings up the pod, all those initializations must happen automatically, and then it has to point to the master. And then finally, even if after that thing has come up, who is going to inform the app about this new replica that is available for serving traffic? So those are the problems that exist if you try to launch MySQL directly inside Kubernetes. So Vitess actually has all the pieces that it takes to run MySQL within Kubernetes without you having to do all these extra steps, because it contains all the glue code in these various pieces. So here's an architectural diagram of Vitess where app server connects through a load balancer through a VT gate. And VT gates are all stateless. So app server would get any one of these VT gates when it makes a connection. And as far as that app is concerned, that VT gate represents, an enormous database in the background. And behind the scenes, it is actually a whole bunch of smaller databases that appear as if they are a big database for the application. So if you look at the VT tablets, they are actually tied to the MySQL. And what they do is they are basically a minder process that makes sure that everything is healthy. VT tablet has a connection pool. It also takes care of doing backups, restores. If a new instance comes up, it takes care of initializing the database. And then the other cool thing that VT tablet does is when it comes up, it registers itself with the topo server. And the VT gates are watching the topo server. And as soon as they discover that there's a new VT tablet that is come up, then they can actually start sending traffic to that new VT tablet. So the cool part of it is that this is mostly a self-managed system. You just like add capacity by bringing up new VT tablets, create new case spaces, and just keep doing them in the background. And these things will magically start to appear for you at the VT gate level, and then the application can start using these things. And then you see that VTCTLD box, which is essentially a dashboard. And using that dashboard, you can perform all your cluster maintenance tasks like resharding, you can do failovers, you can initiate backups. So those are all done using VTCTLD. So to run in Kubernetes, you need these many components because of the rules that Kubernetes sets for you. The simplistic approach of just launching a server inside a pod, even though it will work well in the case of a stateless application, that type of thing doesn't work for a storage system. It's mainly because storage systems have all their own individual rules. MySQL has its own method of replication, which is different from, for example, what MongoDB would do, which is different from what Postgres would do. So each one of those software pieces has a different method of replication, and there is no way Kubernetes as a generic platform can work that intimately to a database. So all this glue code has to be written that manages it and abstracts those details out of Kubernetes so that Kubernetes can then work with you in a generic fashion. Okay. So Kubernetes workloads. So the best part of Vitess is when we built Vitess, we actually initially ran it in Google's Borg, which is a predecessor for Kubernetes. So, and there were a lot of challenges that we had to go through to make Vitess and MySQL work in that platform. And the short story long, when Kubernetes came out, we are pretty much ready for it because it is essentially was following the same ground rules that Borg was making us follow when we deployed Vitess in Borg and got it up and running. And we scaled it to a pretty massive level. Like we had like tens of thousands of shards running on Borg. So when Kubernetes came out, people started asking, it's not recommended that you run databases on Kubernetes. How do you say that you can do it? So, but we had the Borg story to share. Stitch Labs was actually the first company that decided to take this risk, and they deployed Vitess on Kubernetes. And since the day they deployed in 2016, they've been running on Kubernetes ever since. They recently got acquired by Square, so now they finally sunset that system. And what I hear is that they are rebuilding that same system inside Square. So it's kind of exciting. But they were not the only ones. So after Stitch Labs, HubSpot came and said, hey, we like that Vitess can do sharding and etc. It's kind of cool. But the coolest thing that we see about Vitess is the fact that the cluster management features of Vitess. So I think the way we operate, we want to deploy a self-service system for our developers where they can just click, click, click and get their database up and running. And I think Vitess has all the components that it takes to build that. So they came and adopted Vitess and deployed Vitess on Kubernetes, and they've been running on it ever since. And then after HubSpot, there was a company called JD.com in China that just quietly decided to deploy Vitess on Kubernetes. And only a couple of years after they deployed that, they even told us that they did this. But they deployed a really, really massive system. And it was so massive, tens of thousands of tablets, that last year during Singles Day, November 11th, they apparently served 35 million QPS in peak, which is like as massive. I've not seen a QPS as massive as that in many places. And finally, Nozzle is a startup. Like Nozzle used Vitess in Kubernetes. Why would a startup adopt Vitess, right? That's the question that would puzzle you. They were big fans of Kubernetes, but their story is as follows. They actually deployed Vitess on Kubernetes in Azure, and they were running there for a while. But then after a while, GCP gave them a better deal. So what did they do? They just packed their bags and went. So that is the advantage of running your software end-to-end in Kubernetes. There is no vendor lock-in. You can just pack your bags and move anytime you feel like you get a better deal from a different cloud. So there is a different way to look at Vitess. I speak of Vitess as having these three pillars. One is query serving, which is being able to serve queries for you, whereby underneath you can create key spaces and you can shard. So you can serve sharded queries, etc. on one side. On the other side, there is the cluster management, which means that as these instances come up and go down, there needs to be software that puts all these things together and keep them together. So that is the cluster management aspect. If you look at systems out there, many of them actually are starting to give you sharded query serving. There's a lot of distributed SQL systems that are coming up. Such systems also give you cluster management. But the one thing that they do not give you, that only Vitess has, in my opinion, which is the third pillar of Vitess, is vReplication. And vReplication is a huge differentiator. It solves a problem that you will face once you get into a distributed environment. Because once you get into a distributed environment, you want to be able to refactor your data. Right? So we will cover that in a bit. So if you look at query serving, this is what Vitess does for you. It can route your queries. If a query needs to pull data from multiple shards, it will do that. You can specify your sharding scheme, and there is a very formal method to do that using vschema and Vindexes. If you have auto-increment tables that are across shards, you can do those using sequences. So a whole bunch of features. And on the cluster management side, Vitess handles failovers for you. We recently started integrating Orchestrator as a native component of Vitess, which I'll talk more about later. And but then it will do your backup restore, manage all your replicas. And Vitess also is aware of cells and regions, which means that you can deploy Vitess in public clouds, and you'll be able to specify these components, you can, for example, deploy Vitess in multiple zones and in multiple regions, and you can make Vitess understand these concepts and route traffic accordingly. So the third pillar of Vitess, vReplication. What does it do? Essentially, it allows you to transform data from any form to any form. So the biggest problem that developers face today is they don't want to get stuck designing a schema when they have an idea in mind. They just want to write code, right? So the problem that they have with today's databases is that I have an idea, I have code, now I have to sit and design schema. So what Vitess would allow you to do is just put together something. No? Don't worry about how efficient it is. Don't worry about correctness. Just maybe even a key value, right? Just put your data there and start writing your application. And even just take it to production. Take it to production and start using it. As long as it works, why worry about efficiency of the data that it is storing, right? So after a while, you're going to start seeing things that are slower. You're going to want to make changes, right? So in Vitess, what you can do is at that point, say, transform the data, saying that, like, for example, if you had a key value store, you can say, okay, now I want a field of that data to be materialized as a proper column in a table, right? You can split your table into two. Vitess allows you to do all these things in an extremely safe fashion, which means that your app continues to write to the existing data, and Vitess materializes the new form of the data while the app is continuing to work with the old data. And then what you can do is you can cut over your traffic to use the new data. And after your cutover, what Vitess can do is actually reverse the replication and keep the old data up to date. So in case after the cutover something goes wrong, you can actually go back to where you were, right? So you can do that. And so what this allows you to do is essentially refactor data like you would refactor code. These are things that usually take multiple years if you really want to do that. And people end up stressing over data schema mainly because of these problems, because it is hard to really change your data after you've committed to a schema. So Vitess will get you out of that hole. And the same technology you can use to reshard your database. If, for example, you chose a sharding key and you didn't like it and it wasn't really performing well and you felt that a better sharding key would work, you can do that. You can basically materialize your table to use a different sharding key and then cut over to using that new one. You can migrate data into Vitess from another MySQL instance using vReplication. Or you don't even have to get locked into Vitess. If you feel that Vitess isn't working out for you, you can actually, Vitess will let you stream all the data out of your current database. There's for example, Slack had to make a large scale migration. They had 2,000 shards to migrate from a legacy system. They used vReplication. They had to migrate like hundreds of terabytes, and they were serving hundreds of thousands of QPS. And their estimate was to like 4 engineers, 3 to 5 years. And that, in my opinion, that's a very conservative estimate. It could actually take longer than that to migrate data of this kind. So what they did was, with vReplication, there was only one engineer that worked, and I don't even think that engineer worked full time. In 1 year, they were 99% done. They are left with like 3 databases left to migrate, which they will do pretty soon. And all this with zero downtime. Because of the scheme that I explained, the application just kept writing to the old database, and then they just cut over and continued. And all this was done with completely transparent to the application. So the other thing that you are noticing nowadays is there are many distributed SQL systems that are coming up, and many of them are claiming claiming to use these new consensus protocol like Paxos and Raft, and they are supposed to give you better durability and better consistency. People have been asking me, what is Vitess's story there? So Vitess actually, along with using MySQL semi-sync and along with the rest of the glue code that we have written, amounts to what is essentially what we call Flex Paxos. What Flex Paxos is essentially a better way to do consensus. What it allows you to do is actually decouple the durability settings from the number of nodes that are that can be active in the system. For example, in this case, there are 4 regions, and each region has 2 nodes. But in your case, for durability, you may actually just want cross-region durability, which means that if you write traffic, if you write data on one node, as long as it goes to another region, you may be happy, and that may be sufficient. While at the same time, you may want to use other nodes for failover flexibility, serving traffic, or locality of information, and all those things, right? So what we have done is, so I actually have a series of blogs that explains how this approach, using MySQL semi-sync and applying some of the principles of Flex Paxos, you can actually achieve all the necessary requirements that you may have as far as durability is concerned, while at the same time having the flexibility of launching as many nodes as you see fit. The other feature that you can do with using this approach of durability is what Slack engineers call Aurora Mode. So because of the fact that your bin logs are now more or less becoming the source of truth, because you can fail over and continue serving traffic anywhere you like, the durability of a single MySQL instance becomes less important. So what that allows you to do is you can turn off all safety precautions while running a MySQL instance. So in other words, the InnoDB storage that MySQL uses can be treated as ephemeral. So you can turn off all those transaction safeties, you can use buffered IO, and if MySQL crashes, you never do crash recovery. You always go to a backup, restore it, point it at the new master, and let it catch up, and then once it's caught up, do serve traffic. So this gives you the kind of benefits that Aurora scalability can give you. There are also other benefits in Vitess. You can actually, Vitess is a very transparent system. There are manholes everywhere. If something goes wrong, you can open up and go see what is going on inside. At the end of the day, it is MySQL that runs behind the scenes. So you can go in and take a look at every row that you have written, right? And also because of the fact that it is open source and many people are committed to it, the project here is here to stay. So in recap, Vitess has proven scale. You can scale it as big as you want. It can run on Kubernetes. It has some awesome guardrails, which basically deal with react better when there are outages. It is a very transparent system. And last but not the least, you can actually deploy your schema in Vitess with no regrets, because if there is anything wrong, you can always fix it later. All right, here is the time for Q&A. So the first question is, if I'm starting a new project, do you recommend I start with MySQL and later migrate to Vitess, or is it better to start with Vitess directly? So if you had asked me this question 2 years ago, I would have probably said, just go with MySQL, mainly because my setting up Vitess and getting started with it required a lot of learning and a lot of heavy lifting. You had to learn all these components and how they work together. But what we have done recently is simplified all these things a lot. It's a much lighter lift right now for you to get started with Vitess. Vitess comes up a lot better. We have ironed out all the kinks it takes to bring up a Vitess cluster. And therefore, the advantage you get is that you can just get started with Vitess, and then when you need to reshard or split data and stuff, you can do that directly within Vitess instead of launching a separate migration project to come out of your existing MySQL into Vitess. So I would definitely recommend starting with Vitess directly if you think that you will eventually need all these features that Vitess has. The next question, what is the difference between PlanetScale and Vitess? That's a good question. The way I would put it is Vitess is what I would call a project. It is basically something, it's basically like a toy that you play with, you tinker with it, right? Vitess has a large number of ways it can be deployed. It has a large number of options, and you can basically do many trade-offs by configuring things one way versus another way. Vitess as an open source project gives you all those flexibilities to deploy it in many different forms. For example, Kubernetes is not necessarily the only cloud that you can cloud platform that you can launch Vitess in. Like you can run Vitess in Mesosphere if you like, or in Nomad, right? So Vitess is agnostic of all these things, and you can, like many people, run Vitess on bare metal too. Whereas PlanetScale is more of a product. It's kind of an opinionated deployment of Vitess. What it allows you to do, and like for example, let's say you're convinced that you like Vitess, you want to use it, but don't want to tinker with all the options that it has. You just want a running version of Vitess that you want to use. That is where PlanetScale will come into the picture, where you can go to PlanetScale and say, click, 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 I want a Vitess instance that has the following properties, and boom, PlanetScale will launch that for you as a hosted service, and then you can get on with writing your software and just using the backend that PlanetScale provides for you. There's also support that PlanetScale gives you if you want to use Vitess as an open source project. So those are also things that we do. All right, next question. What is the typical recommendation on the number of shards? So the number of shards you can actually, it depends on the data size, essentially. The general guidance that we tell you is about 200 to 300 gigs per shard. So if you have like a terabyte of data, you probably need about 4 shards. And that's, it's more of a thumb rule. These things may change a little bit depending on the kind of QPS or other resource that a shard may max out, right? Sometimes it may max out your memory or max out your CPU. So you may come up with a slightly different set of shards, but 200 to 300 gigs seems to be the thumb rule. In other words, there is no specific number of shards, as you've seen before. There are people that run like 1,000 shards, 2,000 shards. There are people who run like 2 shards, 8 shards. So the numbers vary, but most of them seem to be happy when the shard size is around 200 to 300 gigs. I mean, like there are other advantages to running such small shards. Imagine like the time it takes to deploy a DDL, right? What would be like, could potentially take weeks of deployment can run in like 10 minutes in Vitess because it all happens in parallel in multiple shards. All right, next question. How does schema deployment work in Vitess? Awesome question. Actually, as you may or may not have heard, Shlomi recently joined the Vitess team and PlanetScale, and he is the author of Orchestrator, he's the author of Ghost, and also of Freno. He is integrating all those tools inside Vitess as if they were native to Vitess. So previous to Shlomi integrating these things, what we used to do was we used to tell people to run Ghost from outside, directly applying schema changes into the MySQL instances that Vitess runs, and Vitess will pick them up when it notices that the schema has changed. But now all of that can happen internally through Vitess. Actually, all you have to do is issue your DDL. You issue your DDL, except that it won't be MySQL directly applying it. It's Vitess picking it up. You actually had a directive in there saying that using Ghost or using PT online schema change. We also integrate with PTOSC. And then Vitess will then initiate a workflow instead of applying a DDL, and it will do this entire thing in the background. And it also has enough observability where you can go and see progress. You can watch progress. It also ties into Freno, which means that it will do throttling and make sure that it doesn't overload your master while applying your schema. It's an awesome thing. And there is actually, Shlomi is going to be presenting this in an upcoming conference. All right. Can Vitess partition data by regions? Yes, the reason why it can do it is because Vitess does not have a fixed sharding scheme. All sharding scheme in Vitess are pluggable, which means that you can come up and say, I want a sharding scheme that is region aware, and Vitess can accommodate that. So in that case, then you can say users from region A go here, users of region B go to that shard, and then you can run your masters in different regions, giving users a more snappy experience when it comes to a website. You can also use the same scheme to partition data, make sure if there are rules about where data can be replicated or not, you can control those things also using Vitess, using various configurations. Next question. In Kubernetes, how can I make sure that a replica doesn't run in the same node as the master? Otherwise, I may lose all the data if the node goes down. Yes, that is a problem that used to exist with Kubernetes. When you schedule master and replica nodes, they could actually end up in the same, master and replica pods, they could end up in the same shard. But now there is a new feature in Kubernetes called anti-affinity. You can actually tell Kubernetes not to schedule these pods on the same node. And once you do that, it is guaranteed that a replica node will never run, a replica pod will never run on the same node as that of a master. So you can do that and thereby make sure that if a node is lost, the data is definitely there in a different node, because there will be another pod at least that runs that.